Hello students, this is ISI MSQE 2019 solution of part C. Okay, consider a street represented by the interval 0 to 1. Three agents live on the street. Agent I lives at xi, and assume that all these things x1 less than x2 is x3. Suppose we look at a hospital at point P. So what we say that P is a square optimal of the minimizes this, so derive the square optimal of the value P. So if we take the first order condition, and differentiate this, so the optimal values of P you can calculate will come as x1 plus x2 plus x3 by 3. So this is solved in my other video, so the description part you can see there, the explanations are also being provided. Okay, next is the part B. So we say that the absolute optimal, if it is maximizes summation of xi minus p. So I argue that if p is absolute optimal, then p is this, and use this to derive an absolute optimal of p. So two parts. Let p does not belong to x1 and x3. So we suppose this thing, and then the hospital can be moved to some point, maybe like p dash, which is p of x1, and doing so we reduce the value of objective function. So similar argument applied for x greater than x3. So obviously p is belonging to x1 comma x3. Next, now we know that this p value is between x1 and x3 in the second part. Now suppose x1 less than p less than x2. So then we can put p towards x2. So we can p towards x2, so which will bring the hospital close to two agents. Further from only one. So thus doing so again reduces the sum of absolute distances. So similar argument also goes for x2 less than p less than equal to x3. Thus the optimal of p is x2. Last part of this question coming in. So now suppose that n agents live on the street where x1, x2, x3 xn, and n is an odd number. So derive the absolute optimal p. So using the same idea as above, we can show that the absolute optimal value of p equal to median of xn. So that is x of n plus 1 by 2. So say the hospital is located to the left of the median. That is possible. So hospital is located to the left of the median. Okay. So then bringing it towards the median brings it closer to median, so this is also making it closer to two agents. And who get farther away from it. So thus the median is absolute optimum. So median equal to absolute optimum. Repeating again. So the hospital is located to the left of the median. So then bringing it towards median brings it closer to more agents than the number of agents who get away from it. Okay. So if I just put it, so it will be n, which is maybe n10, and that will be n5. So away from 5 towards 10. Okay. So this is a trade-off type of decision which needs to be taken.